Ladies and gentlemen, allow me to welcome you to today's session. I'll be the chair for this session, and my name is Joyce Kimtai. We have an exciting lineup of speakers this morning, and I would encourage us to pay attention to them, and let's have an exciting and interactive session. Partire da Wimbledon, il Djokovic 6. So this morning, we will have a session on building adaptive capacity for humanity. And we have exciting speakers. We have Barbara Widera who will be speaking to us on nature-based solutions. We have Joachim and Alicia who will be talking about resilient food system. Aditi will be speaking about resilient water access. And Asta will be speaking to us about agroforest. So first, we're going to start with Barbara's presentation on nature-based solution. Welcome, Barbara.
Thank you very much. A very good morning to all of you. So I will just very briefly introduce myself. I'm an architect and researcher currently working at Prof University of Science and Technology in Poland. And for over 20 years now, I've been studying the relations and interdependencies between nature and architecture. So I'm definitely not a climate scientist, but since my focus is on bioclimatic architecture, then I'm probably the missing link between biology, climate, built environment. And today the focus on my presentation is on nature-based solutions in the context of climate resilient buildings and cities. And I have chosen this specific topic because the built environment today is facing a number of challenges. And that was the main reason why I joined the New European Bauhaus Initiative when I had an honor to meet John Schönhuber, who is the father of the initiative, definitely. And so it fits perfectly because the challenges in the built environment can be today successfully addressed with technology that we have, but that usually results with excessive energy consumption. And this is really critical because, as we know, the built environment is this famous elephant in the climate room. It is responsible for around 40% of global greenhouse gas emission and similar level of energy consumption. And in view of the massive demand for energy, humanity under climate stress must simply take measures to reduce their dependency on electricity and fossil fuels, especially for heating and cooling purposes. And to do so, we clearly must accelerate the transformation process from non-renewable to renewable sources, energy sources, combining them with effective energy storage methods. And more specifically, I believe we need to transform building schemes from carbon emitting to carbon sequestrating bio-based envelopes. And definitely we need to maximize energy efficiency. We can do so by regreening them and increasing biodiversity through the green ventilation networks. And I do believe this is relevant because I was raised in botanical garden. When I was 4 years old, my mother, who is a biologist and ecologist, studied the relations between species and competition. So when I was 4 years old, I learned what is biodiversity and how important it is for people and also for the climate, where very few people were discussing that. And a very specific solution that I want to share with you today is how we can do something robust, as we were looking yesterday for some concrete, some robust solutions. So definitely the thing we can do is that we can eliminate air conditioning for public spaces in favor of nature-based solutions, natural ventilation, evaporative cooling, shading, and greening. And that was the topic also brought yesterday by John. Then sometimes we can maybe step out a little bit of our comfort zone to do something for the environment. And that to increase people and ecosystem resilience, which is our topic today, the first thing we need to understand is the interdependencies and the interactions of people and ecosystem, which today, unfortunately, are mostly based on parasitism, which is a correlation in which one partner benefits at the expense of health of the other, while the basic principle of the relationship between people and ecosystem and other species should be to minimize the negative effects of our activity on the environment, taking into account the long-term effect and especially the climate change. And so the optimum scenario beyond 2050 should be to achieve homeostasis on the basis of symbiosis with a minimum requirement to achieve a level of well-balanced competition, which can be also described as sustainability. And the analysis of natural system behavior allows us for knowledge transfer from biology to technical disciplines, including architecture, in purpose to implement natural processes in concepts and structures designed by human. An example of natural system designed to selectively store and distribute energy is the fat concentrated in the camel's hemp, because it enables effective cooling through sweat evaporation on the remaining surface of the body when the animal mass acts as a heat buffer and regulates body temperature. And the reason why I brought it up is that comparable thermoregulation in buildings can be provided through the thermal massing strategy. And nature-based solutions for this strategy could could allow to increase system resilience, carbon storage, improved user comfort, and overall ecosystem and biodiversity. And one of such, I don't want to blind anyone, but one of such a very effective and affordable storage system is earth building techniques, which are sometimes forgotten, but they are in fact very effective, and they include stabilized earthen blocks, super adobe, or hempcrete. So let me share with you one simple example of such buildings. Here, the wall was constructed from bags, simply filled with earth and pressed from the top for stabilization, and then plastered with clay and lime. And this thermal mass is successfully combined with natural ventilation with double roof that supports the convection. So the hot air elimination is fastened, and this building is extremely simple and extremely cheap, because this is the children's land designed in Gaza Strip, while more advanced concepts of building envelopes are designed for building adaptation to external conditions, and they include monitored gas and liquid exchange, which is also comparable to evapotranspiration, and they can be combined with passive night radiant cooling, such as the building that I'm sharing with you, which is Energy Efficiency Center in Würzburg, that some of you are probably familiar with. Then nature-based solutions for the indoor comfort can be based on symbiosis with green plants, which of course absorb carbon dioxide and produce oxygen through photosynthesis. And green zones can be introduced not only on the roofs or on the facades, but also into the courtyards, which is one of the most traditional techniques, but it is very effective since it supports daylighting and natural ventilation. And the test bed of efficiency of natural and technological processes was a Breathe Austria pavilion for Expo Milan. And in this building, it was 2015. And in this building, technological solutions were hybridized with natural processes. So fans, sprinklers, vapor diffusers were powered by a minimum amount of photovoltaic energy, and they very effectively enhanced natural processes to lower the temperature, raise humidity, and maximize carbon sequestration. So the system was calculated for 1,400 visitors per hour. The oxygen consumption were compared to the oxygen production by green plants. And when talking about green plants, when we selected them appropriately, we can create biofiltration systems, for example, biofiltration walls, which can be present both inside and outside the buildings. And we can also combine facades, hybrid facades, with building integrated or building applied modules such as organic photovoltaic cells or microalga biofacades. So they combined sustainable energy production with thermoregulation, and this allows to recover the part of energy which was not converted to electricity. Then organization patterns observed in nature are based on mobility and flows of air, water, energy, and matter. And under natural conditions, animals such as birds or fish develop the ability to adapt to wind or sea currents. And by drawing conclusions from organism responses to the phenomenon of movement, we can design buildings which save energy through reduced resistance and optimized performance. And one of such buildings is the one you can see here on the schedule. And this is in Ningbo, China. And I just checked the weather forecast. Today in Ningbo, it's 44 Celsius degrees. So they do have extreme climate events. And in this building, it is designed, by the way, by Mario Cucinella, about whom we were talking yesterday. And in this building, the shape and ventilation can save up to 30% of energy. And this is because it is designed to respond to climate conditions. So in summer, with the highest position of the sun in June, the solar radiation is reflected from the facade to avoid overheating. And it is combined with correct daylight distribution and natural ventilation, and also some passive techniques such as earth-to-air heat exchanger. This is, of course, experimental building, which was a little bit more expensive, but it shows the opportunities. And in the winter, with lower position of the sun, passive solar gains are possible, and huge amounts of energy are actually saved. And the astonishing fact is that this building, through most of the year, operates only on passive strategies. And solely during the few, about 14 days in the summer and similar number of days in the winter, building management system activates active strategies powered by renewable energy. And so, of course, I'm not going to discuss every detail, but let's try to transfer this knowledge to the urban scale, and the application of understanding of flows and ventilation in urban design results in cooling effect and improved air quality. This is the design by Rem Koolhaas. And here in Bronx, Jose Serrano Center for Global Conservation, the ventilation channels are combined with water bodies to enhance evaporative cooling. And since water particles are introduced into ventilation air, then it is obviously more effective. And in this specific building, it is worth to observe that it is elevated above the surface of the water, so evaporative is even better, even more effective. Moreover, the environmental footprint of the building is minimal. The louvers that you can see, the wooden louvers, are made of former oak barrels from the winery. And the shading strategy with this overhanging roof, it also helps to reduce the temperature gain in summer and good daylighting in the winter. And some of the most effective cooling strategies are again based on nature-based solutions, such as passive downdraft evaporative cooling, which is inspired by the structure of a termite mound, termite dens. And this can be successfully applied, especially in arid climates where not all the options are possible. And this is the cooling tower, which helps to reduce heat in Masdar city. It is currently tested for several years, and it is quite effective because the temperature under the cooling tower is between 5 to 10 Celsius degrees lower than without this device. Also, this double-layered ventilated roof, which can be combined again with photovoltaics, they have sections that shade the facade and help to reduce the temperature, so they bring again the energy savings. And nature-based solutions for energy flows include daylight, electricity production, heat harvesting, and storage. And this follows an observation driven from nature, such as the phototropism, the specific feature of plants that follow the sun to optimize the amount of energy intake by opening up to receive more light and heat and closing down to avoid overheating or excessive cooling. And the concept of climate responsive screens, such as inspired by nature in kinetic facade system, such as that one in Al Bahar Towers in Abu Dhabi, results in 50% of reduction of solar gain and significantly reduced demand for energy for air conditioning. And even better performance of kinetic building, inspired this time by the Falcon wings, was achieved in United Arab Emirates Pavilion in Dubai, designed by Santiago Calatrava. And the roof hybrid system consists of movable carbon fiber wings, which when open allow daylight penetration for the photovoltaic panels beneath them, and when closed, we can see on the left side, it protects the building from the winds, sandstorms, and these cantilevered wings combined with water ponds around the building and native greenery and white color which reflects heat. This all creates a very pleasant and inclusive space around the building. Now, when talking about circularity, this is also a very specific feature of nature because the solutions encountered in natural environment are based on such rules that nothing is really a waste, and we certainly need to apply the same approach in construction sector with the zero waste approach, so it is necessary to reduce negative environmental footprint. And some of the most efficient nature-based concepts include phytopurification and aerating applied to the conservation of soil and water. This was the topic we talked about yesterday. And here I'm showing you a very simple system for rainwater collection combined with phytopurification basin filled with pebbles and Phragmites australis, which is a tortora, and this is combined with overflow system and underwater tank for rainwater collection, because it is crucial today to save drinking water, and then we should fully utilize rainwater and make use of salt water, which is also possible if we use the nature-based solutions, several plants or fishery ponds. Then natural structural systems are characterized by high energy efficiency, by lightweight, and they are fully fit for purpose. The spider web is a perfect example of such a system. And also when we observe how animals, birds, insects build their nests, we can observe that they use the materials, organic materials available in the closest vicinity. So this is also something we can learn from. And trees and plants in the urban tissue provide chilling, shade, carbon sequestration. And I'm sharing with you the beautiful example from Singapore, which is almost on equator. And in this hotel, Park Royal Hotel on Pickering, there is no air conditioning in the public zones, and people are absolutely happy with the temperature because There are green plants that provide shading. There is natural ventilation combined with evaporative cooling. So in all the corridors, in all the spaces, no air conditioning. And my final remark before I come to the conclusion is the observation driven from the ecosystems organization is that species share the territory, such as on coral reef, using only as much as they need. And contemporary preference for large open spaces in buildings can be possibly satisfied with more carbon sequestrating zones, green zones, which can be combined with food production and can be cultivated by those who can dedicate their time and resource to benefit from sustainable urban farming. And then I wanted to share with you an example of coral reef, which represents a very rich biodiversity, when healthy, of course. This system is as complex as city, but also very sensitive. It is based on symbiosis. And just to briefly tell you what is it about, the coral skeletons host algae living with coral polyp cells. Then algae absorbs the sunlight and uses it in photosynthesis, providing energy for coral. And symbiotic algae protects the coral from excessive ultraviolet radiation. However, when temperatures rise, algae would produce oxygen at toxic level and would be expelled by the coral. So algae and coral, they both would die. And this happens if conditions do not change. But the latest observation, actual observation, is that the range of temperature that stress coral to such lethal level is exactly the same range as it is critical now for humanity, and we can observe it in climate change in atmosphere. It is exactly between +1 and +2 Celsius degrees. And I believe that in nature there's no such thing as coincidence, but there are parallels and similarities. So we can use them and we can learn from them. As another stressing factor, except for temperature, is carbon dioxide, because oceans absorb a quarter of anthropogenic, this was the nature calling, anthropogenic carbon dioxide, and then water becomes acidic. So corals weakens and skeleton breaks. And to make the long story short, I argue that in ocean-based climate resilience model, we can compare the surface of a coral, which you can see in the middle, with the building covered with vegetation and even combined with food production. So we can use this model and apply this knowledge in fighting or mitigation climate change. And coming to the conclusions, I just briefly wanted to say that climate responsive building adaptation to the ambient condition in fact resembles biological models in which temperature, humidity, gas and fluid exchange, and also shape and color modification allow organisms for natural adjustment to the environment. And this enables active metabolism, including the improvement of air and water quality, natural cooling, energy, waste management, carbon sequestration. And also, I want to put your attention on the fact that hybrid interaction of biological processes and technology should become a prototype for climate resilient development. And ocean ecosystem model based on symbiosis and balanced competition can be used for the nature-based climate resilience model for the built environment. And as I said, in this model, the living surfaces provide symbiotic shelter for other species in the city biotope. So thank you very much for your attention. I'm fully open for any questions now or later.